Good day, students. Welcome to part 8 of the Algebra 2 CST review. In this installment, we're going to be going over questions 84 through 90. We have some problems involving combinatorics, mainly the expansion of binomials using the binomial theorem and Pascal's triangle, functions, composition, adding and subtracting, and then some problems in series and sequences. All right. So let's go ahead and take a look at question number 84. So in 84, we asked to expand x plus y to the fifth power. Okay? You can make use of the binomial theorem. I like to use the Pascal's triangle for problems of this nature because it's quicker. When we have higher powers, then we need to make use of the binomial theorem. The 5, we can handle it with the Pascal's triangle. All right, so you need to remember that um, the power of the binomial corresponds to a row in the Pascal's triangle, okay? So we're going to the fifth row in the Pascal's triangle, and another critical component you have to recall is that when you're starting your Pascal's triangle, row number 1, the first row is actually row 0. Okay, so we start from row 0, so this is the 0th power. And then row 1 is the next one, 1, 1. This is row 1, and this is row 2, 1, 2, 1. Row 3, 1, 3, 3, 1. You just add the two numbers on top to get the bottom middle number. That's the pattern. And then row 4, 1, 4, 6, 4, 1. We need to go all the way to row 5 because this binomial is being raised to the fifth power. Okay? So the last row that we need is 1, 5, 10, 10, 5, 1. All right? So this would be the coefficients of my expanded form. So let's go ahead and line them up, and then we're going to expand it, okay? So the reason why I can conclude that these are my coefficients is because there's a 1 here and there's a 1 here. If there were 1s here, then this would not be my coefficient. It would be a multiple of my coefficients, all right? So let's line it up. We have 1, 5, 10, 10, 5, and then 1. Okay? All right, so I'm going to basically take the first term in my binomial. I'm going to start with the fifth power, and in this one I'll start with the 0th power, and then we'll just do a power switch all the way down. Okay, so this would be, the first one will be x. I don't need parentheses, it's just by itself. So x to the fifth, and it's going to go from the fifth all the way to 0. Okay, so x to the fifth, x to the fourth, x to the third, x to the second, x to the first, all the way to 0. Okay? And then the second term in my binomial right here, positive y, is going to start from 0. Let me put in green so you can see, and then it's going to go all the way up to 5. All right, so y to the 0. Note that the powers always have to add up to this power right here, 5. So 5 plus 0 is 5, and this will start going up. Okay, so y to the first, y to the second, y to the third, y to the fourth, y to the fifth. Okay, you see how this was 5, 0, and it switched all the way to 0, 5. That's how you do it. All right, so let's multiply, and then we're going to add all the product of these terms, and that will be our binomial expansion of x plus y to the fifth. All right, so the first term, y to the 0 is just 1, so we're going to have x to the fifth, and then this is going to simply be 5x to the fourth, and this term will be 10x to the third y squared. We can even stop right here and look at our options and see which one matches. We know A and B are wrong already because it's not x to the fourth. It's either C or D. So C or D, we have x to the fifth, 5x to the fourth. Oh, I left out my y. So there's a y to the 1 there, so I can put a y here. Okay? So they match. And then this one has 10x squared y squared, but this is 10x squared, 10x cubed y squared. So we can clearly see that the answer is option D. We didn't even have to complete the whole thing. But if you want to complete the whole thing, you can go ahead and do it. So you have 10x squared y to the third, and 5xy to the fourth, and then the last one, the x goes to 1, so is y to the fifth. So if I add all this together, that will basically give me the expansion, okay? So it's going to be x to the fifth plus 5x to the fourth y plus 10 x to the third y squared plus 10x squared y cubed plus 5xy to the fourth plus y to the fifth. Okay? The answer is option letter D for number 84. Alright, let's move along to 85. Question 85, it says, what is the sum of the infinite geometric series? So you need to remember what the formula for the sum of the infinite geometric series is to do well on this problem. So I'm going to use S infinity to represent the infinite sum. It's given by the first term, A1, divided by 1 minus the common ratio. Okay? So remember, A1 is first term, and R is the common ratio. Okay? Because these are the definition of these variables. Alright, so we need to find the first term. The first term is what shows up first. So A1 is 1/2. The common ratio, A is R. The common ratio you find just by dividing a term by the term before it. Okay, so common ratio you can do A2 over A1, A3 over A2, A4 over A3, whatever. You get the same common ratio. Okay, so I'm going to do A2 over A1. So A2 is 1/4. That's the second term divided by the first term, which is 1/2. So, oh man, we have two fractions we have to divide. So this looks like a mess. So how do we handle this kind of situation? So to do this, we can just rewrite division in a different way, okay? Dividing is the same thing as multiplying by the reciprocal of the denominator, right? So I can drop the top, change the division to a times, and then flip the denominator into reciprocal, okay? So 1/4 divided by 1/2 is the same thing as 1/4 times the reciprocal of 1/2, which is 2 over 1, all right? So that's how you divide fractions. All right, so 2 goes here 1, 2 goes here 2, you multiply across, you get 1/2, all right? So we have a common ratio. Now let's go ahead and find out what the infinite sum is, since we have the two components we need. We needed A1 and R, right? So S infinity is going to be A1, 1/2, divided by 1 minus R, which is 1/2, okay? Alright, so the numerator stays the same, 1/2, and the denominator we have 1 minus 1/2, which is 1/2. We have the same situation again. Remember how to do this? When you're dividing fractions, or you have a fraction in the denominator, just multiply the numerator by the reciprocal of the denominator, okay? So 1/2 times 2 over 1, multiply across 2 over 2, or you can reduce and multiply, but you always get 1. Alright, so our answer to number 85 is option A. Alright, now let's move along to the next problem. Alright, so let's take a look at problem 86. 86 says, what is the nth term of, what is the nth term in the arithmetic series below? So we have an arithmetic series right here. So what's the formula for the nth term? You need to remember your formula for the nth term of an arithmetic series in order to be able to do this. Or you can look for a pattern to figure this out. Okay. So let me write down the formula. An, the nth term of an arithmetic series, is equal to the first term plus the number of terms minus 1 times the common difference. Okay. All right. A1 is the first term. So in this case, A1 is 3, the first term. N is the number of terms. We're asked to find the nth term. So guess what? N equals N. D is a common difference, which we can find by subtracting A1 from A2. So 7 minus 3 is 4. So there goes your common difference, okay? All right, so let's put everything together. You have An equals the first term, 3 plus N minus 1 times 4. So we simplify this expression. That should give us what the nth term of the arithmetic series is, all right? So let's go ahead and simplify that. So we're going to have 3 plus, if you distribute the 4, you have 4n minus 4. Simplifying further, the 3 and the 4 are like terms. So it's 4n. Positive 3 minus 4 is negative 1. So an is equal to 4n minus 1. Final answer is option D. All right, let's move on to number 87. Number 87, It says which expression represents f of g of x if f of x is x squared minus 1 and g of x is x plus 3. Alright, so this is a composition problem. What does that mean? It basically means that you're making up a function by placing a function inside another function. Okay? So this is composite because you have an outer or parent function f and you have an input function g. Okay, so that's what a composite function is. So what does this mean? This complicated symbol, what does this mean? It just simply means that wherever we have x and f, you plug in g into it. Okay, plug in g into f wherever we have the x. Or you basically, wherever we have the x's and f, substitute it with the value of g. Alright, so let's go ahead and do that. So first thing I'm going to do is let me call the parent function. The parent function here is f of x. And it is equal to x squared minus 1. Now I need to find f of g of x. So it's going to have an input function. What is the name of the input function here? The name of the input function is g of x, and the value is x plus 3. So what I'm going to do is let me clear out the x's first. So I took the x out here for the name. And on the right side, I'm going to take out the x because I'm going to put in the value of the input function. So what is the input function? Is g, right? We stated it earlier here. G of x is the input function, and its value is x plus 3. So here we're going to have f of g of x, and the input is x plus 3. Alright, so we simplified it, so hopefully we get a match, we get a correct answer. So let's go ahead and do that. X plus 3 square is x plus 3 times x plus 3 minus 1. Okay? Alright, let's simplify this. You just distribute it, or you can use the formula for squaring binomials, but let me do the long way. So we have x time first, outer, 3x, inner, 3x, last, 9 minus 1. Just distribute, okay? Alright, so if you do that, this is x squared, sorry about that. If you do that, we simplify, we have x squared plus 6x plus 9 minus 1 is positive 8. So we clearly see that our answer is option letter B. Alright, let's move on to question 88. So in question 88, it's composition, but at a point, okay? We're evaluating the composite function at a particular x value. So we have f of x is 3x squared minus 4, and g of x is 2x minus 6. We have to find g of f of 2. There are two ways of doing this. I'll show you the quickest way of doing it. That doesn't involve much work. So this one involves first of all, finding the value of the inner function and then plugging the result into your outer function, okay? So first you plug in 2 into f. After you're done plugging 2 into f, you plug in your answer into g, all right? Double evaluation. So that's the quickest way of doing this. Another way you can do this is find f of g of x, find g of f of x, and then plug in 2 into your final answer, which is a little bit longer, okay? All right, so let's do step 1. We start from inside and work our way out. What is f of 2? What on earth does that mean? It simply means anywhere you have x in f of x, you substitute it with 2, right? So since f of x is 3x squared minus 4, f of 2 is going to be 3 times 2 squared minus 4. Okay, that's what f of 2 is. All right, let's simplify these using our order of operations. You do exponents first before you multiply. 2 squared is 4. So we have 3 times 4 minus 4. 3 times 4 is 12, minus 4 is 8. Okay, so are we done? No, see this option here? See that's a trap, okay? We still have to plug in our answer into g. Okay, so the question said, ask us to find g of f of 2. But guess what? F of 2 is 8, so now this problem now becomes g of 8. Alright, so what is g of 8 is what you get when you plug in 8 into your function. So it's going to be 2 times 8 minus 6. 2 times 8 is what? 16. 16 minus 6 is 10. Final answer is D. Alright, so there you have it. Alright. Now let's take a look at question 89. We're asked to find f of x plus g of x. So all you simply do is you add these two functions, alright? So we're going to find at 89. Supposed to find f of x plus g of x. Okay? F of x is good to go. It's already in expanded form. X squared plus 2x plus 1. But take a look at g of x for a minute. It's so unprepared for addition. It still needs to be processed, right? We need to simplify this, expand this completely so we can add it to f of x, all right? Because you see our options here, they're all in expanded form. So to do this, what we're going to do is we're going to expand this one completely. So how do we expand this? Do we distribute the 3 first or do we square first? That's the question. Which one do we do first? You remember, please excuse my dear Aunt Sally, right? What is that? That's the order of operations, right? Please excuse my dear Aunt Sally. You do the exponents or exponents slash parentheses first before you multiply, right? So exponent and parentheses comes first before you multiply. So we have to exponentiate first. So you have an exponent here. We have to distribute that first before we do this 3, or else we'll get it wrong, all right? Okay, so let's go ahead and do that. We're going to have 3 times x plus 1 times x plus 1. X plus 1 square means 2 copies of x plus 1 distributed. Alright, so we're just going to follow this out. First, outer, inner, and last. Okay, so we're going to have 3. The first is x squared, outer is x, inner is x, last is 1. And then we're going to have 3 x squared plus 2x plus 1. And then you distribute the 3 to everything. And then you're going to have 3x squared plus 6x plus 3. Okay? All right, now g is completely processed and it's now ready to be combined with f of x. All we just have to do is line them up by degrees and then we will combine. Okay? All right, let's go ahead and do that. So we're looking for, the question asks us to find f of x plus g of x, okay? So what is that going to look like? F of x is x squared plus 2x plus 1, okay? And then we're going to add the g of x we just got here, 3x squared plus 6x plus 3. Notice how I lined up the degrees, right? So that I can add without making any mistakes. We're just going to be combining the coefficients here, so don't add the degrees, please. So we're going to have 4, 2 plus 2x plus 6x is 8x. And then imagine there's a 1 here, okay, in front of the x squared. So 1x squared plus 4x squared, plus 3x squared is 4x squared. And that basically goes your final answer, which is option C. Okay? All right. Now let's go ahead and take a look at question number 90. It says a math teacher is randomly distributing 15 rulers with centimeter labels and 10 rulers without centimeter labels. What is the probability that the first ruler she will hand out will have centimeter labels and the second ruler will not have labels? Okay? Remember that the probability, let's write out, this is question 90. Probability of an event is possible outcomes divided by total outcomes, success plus failure, okay, everything together, okay, possible outcomes divided by total outcomes. Okay, so in this case we have 2 probabilities here. We have probability of label and probability of no label, okay. So let's say L, put it down here, L is label and NOL is no label. All right, I gotta declare my variables so people don't get confused. All right, so whenever you have an AND, this basically means you multiply, okay? So what is the probability that you're gonna get a label? So how many rulers are there in all? It's 15 plus 10, right? So total outcomes is 25 for the first pool. And how many possible rulers can come out with labels? There are 15 that have labels in there, okay? So that goes the probability for the first event. The second event, no labels. We've already pulled out one. Okay. How many of them do not have labels? With no labels, there are 10 rulers that do not have labels. Out of how many? We already pulled out one, so we're left with 24. Okay. Alright, so let's go ahead and simplify that. We can reduce both fractions. This one on the left I can divide by 5. Since they both end with 5, that means they're divisible by 5, okay? So if I divide this by 5, 15 divided by 5 is 3, 25 divided by 5 is 5 times, and then this one right here I can divide by 2 since they're both even. Divide by 2, divide by 2. 10 divided by 2 is 5. And then 24 divided by 2 is 12. Okay, now I can cross reduce. 5 goes into 5 one time, once. 3 goes here once, and 3 goes here 4. Multiply across, your final answer is going to be 1 over 4. So our answer is option letter B. Alright, so there you have it. So thanks so much for taking the time to watch this presentation. Feel free to subscribe to my channel by clicking up here, and you can click like if you liked this clip. More clips can be found on myclipserve.com, and please post a comment to let me know what you think about this presentation. Thanks again and have a wonderful day.